Hello, students. Today we will be going over 5.4, which is page 117 in your green packet. And our objective is I can use inequalities to solve word problems. And it says write an inequality for each situation. A bus can seat at most 48 students. So the key words here are at most, because people tend to not know exactly what that is. Think about if we had at most 100 people in this room, that means we would have 100 or less people in this room. So we're going to use B because that's a bus. At most is going to be less than or equal to, and this one was 48 students. And that's what we write there. So if you see at most, go ahead and put this above the words at most, so it's less than or equal to. Next one, in Utah, you must be at least 16 years old to obtain a driver's license. Now, you can also ask yourself, can you be 14 years old or 13 or 12 and get a driver's license in Utah? No, so at least does not mean less than. So if you're at least 16, that means you could be 16, 17, 18, or 19. So your age at least is going to be, and put this sign above it, greater than or equal to. Okay. All right, a plane must travel at least, okay? You're going to go ahead and do that. We can pause the video and have you fill out the rest of these, okay? All right, I can do the children younger than. Actually, I think you can do that. And you can do the rest of those, and we're going to go ahead and pause the video, you fill that out, and then we'll go to the practice. Practice on this same page. Jen has $32. I'm just trying to make sure you can see that okay. There's a little bit of a glare right there. I'm not sure what it's from, but I'll just read it and you can infer what it says. Okay, Jen has $32 to spend on dinner with her friends. She purchased sodas and brownies, which cost $5. If the entree, do you guys know what entree is? That's kind of a fancy word, or another word we can put, and I'll have you write this on there. If the entree cost, and the entree is kind of like the main dish, so I'm just going to put dinner. And you can cross it out and put dinner as well. If the dinner costs $9 each, what is the maximum number of dinners she can buy? So when you're defining a variable, that means we're going to put a letter down, and that's going to equal what we're trying to solve. So we're going to put D equals number, this was number before it became hashtag, of dinners she can buy. Whoop. Okay. So we write an inequality, okay? So we're going to circle all the information we know, okay? She has $32 total, so we can write total right there. Okay. She purchased some brownies and sodas, $5. So if we see $9 each, we can go ahead. Remember, we're going to start with y equals mx plus b, and then we're going to change that. Okay, so we get y equals mx. So it's, what is each? $9 each, 9 dinners, plus we have to remember she spent $5 already. Okay, so now we're going to go ahead and write, and that's, I wrote an equation. Now I'm going to write the inequality. Okay, so the total amount is going to be y, so we're going to say $32, and that is got to be, actually I'm going to switch that around a little bit and say 9D plus 5. That total has to be less than or equal to $32, her total. Okay. Now we're going to go ahead and solve to see how many dinners she can buy. So if I have 9D plus 5 is less than or equal to 32, we're going to solve for D. Minus 5, minus 5. Bring this down. 9D is less than or equal to 27, I believe that is. Then divide by 9. D is less than or equal to 3. Okay. So we're going to check that. Let's check it first before we write our answer in a sentence. If she buys 3 dinners cost $9 each. So 3 times 9 plus the $5, is that less than or equal to 32? Okay, 27 plus 5 is 32, so that is less than or equal to 32. So, sorry about that, I'm a little bit off the edge there. Okay. All right, so we know that the most she can buy is up to 3 dinners. So we're going to write that in a sentence right here. Okay, so we can put, and I'm going to write it down here first. Jan, and you could be writing this down too, can buy up to 3 dinners. Or you could put 3 dinners or less. And you can pause the video if you need to write that down. Okay. Okay. All right, you'll have the next 2 pages to do. I'm trying to think if there's any hard ones here. Okay. Okay, we might go ahead and do number 2. Derek has 54 feet of fencing. This is a little bit of a trickster, and I didn't get it ready, but sometimes it's best to draw a picture. So on 118, Derek has 54 feet of fencing for a dog run. His dog run is 17 feet long. At most, how wide can he make the dog run? Okay, so here's number 2, and the best thing to do is draw a picture. Okay, here's his dog run. And he says it's 17 feet long here. And if it's a rectangle, 17 feet there. We're going to assume it's a rectangle even though it doesn't tell us. Okay, so here's our width and here's our width. We don't know how long to make it, but he's only got 54 feet of fencing. So our variable W equals the width. That's what we're trying to solve. Okay. Write an inequality. Okay. So we have 17 times 2 plus we have W plus W. And that has to be less than or equal to our 54 feet of fencing. Okay. Then we go 34 plus 2W is less than or equal to 54. Okay. All right. I'm going to leave it for you to finish the rest. You can do it, students. You rock.